All right, so let's get started. Section 8.4 is system of nonlinear equations in two variables. Okay, so the linear equations, we talked about the systems of linear equations, and the linear was a straight line. Nonlinear means non-straight line equations. Now, one of these, as part of the system, could be a linear, but one of these is a nonlinear. So it could be an exponential, it could be a quadratic, other things that are non-straight lines that we've looked at. Okay, we could even do one of them being irrational. Okay, but we're going to look at a couple of sections, okay? So we can do the very same thing as we did before. We can do a nonlinear system of equations by substitution. Sometimes we can do the addition. Sometimes addition gets us nowhere, okay? Substitution is always going to work. Sometimes the addition method works. And this is the preferred method if you can get it, going. It's less work than going through here. Okay. So let's see what we mean by substitution. Okay, so if we graphed both of these equations, okay, this is what we would get. If I graph this piece of it out, and notice this isn't a function, it's not, it's not a function, not one-to-one, none of that kind of stuff. But I can graph this equation that turns out to be not a circle, but like an ellipse. And then I have x minus y is equal to 4. Okay, which is a linear equation. And when it says solve, you're looking for an x and a y, just like we did before, that solves both of these equations when we plug that x and y in. Okay, so if I'm doing it by the graphical method, I would go to Desmos, graph them, and then identify where these two cross, and that would be the solution. The x, this xy, and then x, that xy, and I'd write them as a solution set as an ordered pair. So here, when I had the linear equations, I would only have one solution. Okay, so for a nonlinear system, I may have no solutions, I may have one solution, this could just touch, or more than one solution. And I could have a couple, I could have actually 4, depending on what I'm looking at, okay, depending on the system. Okay. So let's solve this by substitution. So I'm going to do some work out here. So I may kind of spin this thing sideways, bring this out. Let me get a little more room this way. And then do x squared plus 4y squared is equal to 16. And I might get, because I got to expand this out. Okay, and then x minus y is equal to 4. That's my system. But I'm writing this over here. I'm going to solve for one variable. It doesn't matter which, and then I want to solve for the other one. So this is easy if I just solve for x. So plus y, that's going to give me y plus 4. Okay. So this is my equation 1. This is my equation 2. I solve for one of the variables, and then I'm going to put it into the other one. I can't put it back in here. That gets me nowhere. That would give me y plus 4 minus y. The y's go out. 4 is equal to 4. It's an identity. It's the same form. Okay. So I'm going to put this into here. So wherever I see the x, I'm going to put my stuff here. Y plus 4 squared plus 4y squared is equal to 16. And let's see what we get for this, okay? So I square this out, and I'm going to get y squared, multiply the 2 together, 4y, doubled is 8y, and then square the last one is plus 16, plus 4y squared is equal to 16. Okay? So here, I add these things up, 5y squared plus 8y plus 16 plus 16. If I subtract 16 from both sides, I see a quadratic, I would like to get it to this side, but when I subtract 16, this goes out. So I get this equal to 0. So now, I see I can factor out a y. And the only way I can get two numbers multiplied together to get 0 is either this is 0 or 5y plus 8 is equal to 0. So here's my 0. If we go over here, here's the y is equal to 0 all along here. That's that point where y is equal to 0. And then here, minus 8, that's 5y divided by 5, so that's minus 8/5. Okay, so this would be the minus 8/5. That's negative 1 3/5. That looks right about there. Okay, but that only gives us the y value. You need the x's. Okay, so you've done your work. Here's the x in terms of y. So for this, your x is equal to 0 plus 4. So your solution is just 4, 0. That's this piece, 1, 2, 3, 4. And then here, x is equal to minus 8/5 plus 4. This is 20 over 5. 20 minus 8 is 12/5. 2 2/5. 2 2/5. 1, 2 2/5. And a fifth. 2/5 right there. Okay, so my solution looks like this. Here's my 12/5, comma, minus 8/5. That's my solution set here and here. Okay, so let's go through another one. Let's go and take a look at another one. Okay, so 4x squared minus y squared is equal to 4. And let's do minus, just do the whole thing. Y is equal to 1 minus x. Okay. So if I graph these in Desmos, this is kind of what I look at here. X has to be, for this one, 1 minus x has to be greater than or equal to 0. So 1 has to be bigger than or equal to x. This is the small size. So this is negative infinity to 1. Okay, these are all the smaller than the 1 included. So over here you see this is the graph of this one, and this there is two versions. So if I solve this, 4x squared minus y squared is equal to 4 for y. 4 square x squared is equal to, minus 4. So I'm going to bring the 4 over here, the y squared over here, and then if I solve this, it looks like that. Okay, I've got two versions for y. I've got the plus version and then the minus version from those. Okay. So what I want to do, I've already got this for y, so I'm going to substitute that directly into there. Okay, depends on the form of the system, but I want to do substitution, so I'm looking to get one of these in here. So if I do this, so this is equation 1, equation 2, 2 into 1, then I get 4x squared minus like that. And then the y over here is equal to the square root of 1 minus x. I want to get rid of all my y's, okay? And this one was squared from there. Okay. So this part of it, squared was equal to y, but here I've already got the y as well. I plug them into all of these, and now I come out with 4x squared. Square root, the square just gets rid of the radical. This is now 1 minus x, because I've got a negative that I have to distribute, and that's the square root of 1 minus x. Okay? Four x squared plus x minus 1. Now, if I square all that to get rid of this thing, that's going to be a pretty big problem. Oh, I'm sorry. This was 4. That wasn't this. Okay, I knew that was going to be a big thing. This was supposed to be 4. Sorry, that was not a y. So 4, that helps me out here. I knew we were going to get a big thing here. So this is 4x squared minus 1 minus a minus x gives me the plus x. That has to be equal to 4. Quadratics always have to be equal to 0. So I'm going to do a minus 4 from both sides. Minus 1 minus 4 minus 5 is equal to 0. Okay, so if I try to factor this, do quadratic equation, I can also try to factor. So let's go with a couple of different ones. Since I've got this, I'm going to do this a little different. I know what one solution is. This is 1. Okay, x is equal to 1 matches this. So I know I have a root of 1. So let's do synthetic division. Instead of trying to factor, I'm going to use this information to do one of these things, and I should have it. 4, 1 times 4 is 4, 5, 1 times 5 is 5, 0 says indeed that is, that's the other factor, okay? So my root is 1, x minus 1. The other one, I reduce the degree by 1. That's the coefficient, 4x plus 5 is equal to 0. 4x squared plus 5x minus 4x, that gives me the plus x, and then the negative 5. Okay, so I just used whatever information. Instead of doing this trial by error, I thought we could use the information here. Okay, and then use our review of synthetic division. So here x is equal to 1, and then x is equal to minus 5/4. Minus 5, and then divide by my 4. Okay, so once I get these, I have to go back and put it in here. My corresponding y value for 1 minus 1 is 0. So my 1, 0, that's what we see here. And then 1 plus 5/4, this is 9/4, minus a negative 5/4, so that's plus 5/4. 4 over 4, 4 plus 5, so my y would be the square root of 9/4. Square root of the top, square root of the bottom is just 3/2. Okay, 1 1/2, 1 1/2, right there for my negative 5/4. All right, so let's go on to another one. Let's just work another couple. some of these you can do addition. Some would be, pretty messy trying to do addition on these things. If I went back, if I tried to add these things in, I've got a mixture of y and x's square root, so I've just got a big mess in here. Now I've added to a y, and I'd have to square out this to get rid of this thing. So I would have to do y squared and then stick a 1 minus x in here, okay, which is the substitution. But the addition, there's no linear combination that gives me these two things, okay. So here's another one that I couldn't do addition on. So if I did my 2x plus y is equal to 5, and then I had x squared plus y squared is equal to 50, I couldn't multiply this by any numbers to get, so if I multiplied this by 2, I'd have 2x squared. I still can't subtract out this or subtract out that. Okay, so there is no addition method that I could use for this. I can't do it, okay? But I can do the substitution in here. And that just says solve one of these for the other and then put it in and then solve that, okay? So if I solve for y squared, I have no y squared. That's not going to do me any good. I'd have to take the square root and then get some square roots in here. That's not a good choice. I could choose either one of these. Okay, let's go. I've got an x. I don't want to solve for this. If I did for x, I'd have like 5 minus y all over 2. I don't want to square all that stuff. I get fractions. So I'm just going to do the y. So from here, subtract 2x, I get my y is equal to 5 minus 2x. Okay, and then I'm going to put that into there and square it, okay, into 2. So my x squared, that's what my y is. I have to square it. There's my 50, there's my x squared. So x squared plus square the first, 25, multiply the 2 together, negative 2 times 5 is negative 10, and doubled is minus 20x, and then square the last one, square squared, 4x squared is equal to 50. Plus, so I get to drop these because of the plus, I don't have to change signs. And then I'm going to group, this would be 5x squared minus 20x, I still have that, plus 25 is equal to 50, but then I'm going to subtract 50 from both sides, and that gives me 0. I'd like to get a 5 out of these. I'd like to make this 1 to ease a factor. So if I go 5, x squared minus 4x minus 5, I divide by 5 for each one of these things. 5x squared minus 20x minus the 25. Okay. 5 is never equal to 0, so I don't have to worry about that. This piece, 2 factors of 5. If I differed, can I get this number? And I can, 5 and 1, sign of the largest being 5, then x plus 1, x squared plus x and minus 5x gives me the negative 4x and then the negative 5. So x is equal to 5 or x is equal to negative 1. And since I've used this substitution, I've already got this stuff, so my y would be equal to 5 minus 2 times 5 is negative 5. And here, 5 minus 2 times negative 1, that would be plus 7. Positive 2 and 5 is my 7. So for this solution, I get 5, negative 5. And for this one, negative 1, 7. These are my two solutions. I should go back and check each one of these things. So here, 10 minus 5 is 5, that checks. 25 plus 25 is equal to 50, that checks. Okay, how about this one? Negative 2 plus 7 is 5. 1 plus 49 is equal to 50. Both of these check. Sometimes I'll introduce solutions, so I need to go back and check to make sure both are solutions when I come up with it. Okay. All right. So that's the substitution. Now let's go over by addition. And again, this works. This is the easiest in general for me. Less calculations like this and going through. If you can use it, but not, you're not guaranteed that you can use this thing. Okay, so let's see when we can use it. And what am I looking for? Both of these are nonlinear, it doesn't matter. But what I want to be able to do is when I subtract out, I only have one variable, so y squared. I could have a y here, that would be okay, but I want to get rid of one variable. And here, if I just subtract that, I get rid of all of the x's. Okay, here are the solutions if I graph this out in Desmos and this out. This is kind of what I would get. Okay, and it looks like I would have 4 solutions where these crossed. Okay, but I'm going to do by addition. Okay, so let me bring this over. Let me kind of do this. Bring this down so that I can kind of keep a running tab on this. So here I've got x squared plus 5y squared is equal to 25. I've got my x squared minus 4y squared is equal to 16. I've got an x squared and an x squared. I have to do some preliminary looking. So I could subtract this out. I'm left with a y squared, and constant. These are okay as long as I could add a y, because then I have a quadratic left over. I can solve quadratics. I don't want to make sure of y squareds and x's. If I can't get rid of all of the variables at one time, I can't do this. But here, if I subtract, here's my 1, here's my 2, this kind of locks these things as I solve this as a system. I'm going to subtract this, okay? So x squared minus both sides, minus x squared, that gives me 0x squared. So that gets rid of this. 5 minus a minus 5, that gives me plus 9y squared side, plus. And then 25 minus 16 gives me the 9. Okay? So 9y squared is equal to 9. Divide both sides by 9. Y squared is equal to 1. 9 over 9. And then I don't care about y squared. I want y. So I take the square root of both sides, plus or minus. So y is equal to plus or minus 1. And if I go over here, and if I look, I see that plus 1 and minus 1. But look, I'm going to have 2 versions of x. This is the one that I've solved for. So plus and minus 1 is my x. My y. Plus and minus 1. I don't have an x yet. So I've got to go back through and solve for my x. Okay, so, and I've got to do 2 versions of this thing. Okay, so let's go here, let's do x squared. So for y is equal to 1. X squared minus 4, 1 squared, so this is 4, is equal to 16. plus 1 squared is 1, so that's just the 4. What did I get? Make sure I got this right. X squared minus 4. Yep, this is going to be right. So x squared plus 4 is 20. And then x is going to be plus or minus the square root of 20. This is 4 times 5. So plus or minus, take the 4 out, is 2, the square root of 5. This is like 2 point something. So 2 times 2 is 4 point something. And over here would be my x's where this crossed. 1, 2, 3, 4. And then the square root of 5, like 4.2 or something in here. Okay, and then my y values is the plus and minus 1. Okay, plus or minus the x's, plus or minus. So the way this looks out for this piece of it is y is 1. I've got plus 2 square root of 5, 1, and minus 2 square root of 5. Now I get to do this for negative 1. Okay, I'm sorry, for y is equal to negative 1. And this turns out just to be the same for this case. I still get y squared minus 4 times y squared. The negative 1 squared is still the 1. So that gives me this, okay? So plus or minus, this would be the plus 2 square root of 5, 1, minus 1 minus 2 square root of 5. And then when I do this one, this gives me the minus 1, 2 square root of 5, and then minus 1 minus 2 square root of 5. So I get all of these solutions, 4 solutions from here. This doesn't always happen to be the same. I could have very different solutions for this side than that side. But that gives me the 4 solutions that I was looking for when I graphed this out. So I made a correction on here. This should have been, I had this thing switched around. These were the y values, okay, and here's where the corresponding x values, and I should have had x, y. So for each one of these, plus square root of 20, which is the plus 2 square root of 5, I had a plus 1, that's the plus 1, and then 2 square root of 5 minus 1 for this version, minus 2 square root of 5, okay? So for 1, I had 2 of these versions, this one and this one, and then for negative 1, I had 2 x's, sorry, this is, for my negative 1, I should have 2 solutions here, like that. And that corresponds to this over here. So when I came out with the 1, I had plus or minus the x version, and then the negative 1, I had plus or minus the x version. So here's the negative 1. Here's the plus, and here's the minus. Here's the plus and the minus for the y is equal to plus 1. So 4 solutions is what we were looking for when we did the graph. Okay, x's, and then the y value. So maybe we need to do another one just to kind of clean this up again. So what I was looking for is being able, when doing addition method, is to be able to subtract and get rid of all like x's or all y's and just leave with the other variable, okay? And it's just, you kind of need to look at them to see which way we need to do, okay? It is look at it and then kind of think it through which way is going to give you the best. Okay, so I have 2 that's in this form, 16 minus y squared, and then I have 2x squared plus 2y squared. This is what I'm starting out with, is 8. Here I've got an x squared and a y squared across here. Here I've got them on both sides. So let's bring this thing over on the same side. So x squared plus y squared is equal to 16, right, plus y squared. And then I've got 2x squared plus 2y squared from this one is equal to 8. Okay, now look at here, look at the bottom. If I graphed out these two, I don't see any intersections. So I'm expecting no solutions out of this, but let's see how we go about and getting this, okay? So I'm going to multiply this thing by 2. I'm just focused on my x squared. I would like to get rid of one of these things, so I'm going to make this 2. It's easier to do because just multiply by 2. So row 1 times 2, that's my new row 1, looks like 2x squared plus 2y squared. 2 times 16 is 32. And then I have my 2x squared plus 2y squared is equal to 8. It looks like there's going to be a problem right there, right? Is 2x squared plus 2y 32 or 2x squared plus 2y squared equal to 8? This is the same thing. But if I don't notice it, and if I'm just focused on getting rid of my x squareds, I subtract this off. 2x squared minus 2x squared, 0x squared. 2y squared minus 2y squared plus 0y squared. 32 minus my 8. That gives me my 24. 0 equal to 24. When in the heck is 0 ever equal to 24? Never. That says no solution. Okay? There's no way that I can get this and get this to be two numbers. It's the same operations. Okay? And if I look over again, if I look over here, I see no intersections between the blue. This would be the big one. This would be this and that one, which would be there. Okay. Okay, so let's try this. Two over x squared minus 1 over y squared is equal to 5. Okay. So here, I want to be careful when you're looking at these problems to see if I have like opposite signs or same signs. And here, this is the same as this, same sign, so I just want to do a subtraction, okay, to get rid of that. Now here, I get 1 over x squared minus 2 over x squared, okay? Then this minus 1 over x squared plus minus 1 over y squared, sorry, that's 0. And then 1 minus 5 is equal to negative 4. Okay, and then now I just need to solve this. Okay, 1 over x squared minus 2 over x squared is 1 over x squared equal to negative 4. Clear fractions. So this cancels. So 1 is equal to minus 4x squared. Divide both sides by negative 4. X squared is equal to negative 1/4. When is a square number equal to a negative? No solution for that. Okay, I have complex solutions, no real solutions. So no real solution. Maybe I should add that for us. And if I have no real solutions for x squared, there's no reason to go put this back in and solve for y squared. Oh, wait a minute. Hold on. Hold the boat. I jumped solutions. 1 over x squared minus 2x squared. This should be minus 1 over x squared is equal to negative 4. Aha. Then both sides by x squared. Now we get it. X is equal plus or minus square root of 1/4 is just plus or minus 1/2. My bad. Okay, so once we get this, then we need to go back and put them into the original and solve. Okay. If I'd have come out with the other way, then I would have had no solution. So if this had been the other. So if I'd have changed the sign on this, then this would have been something with a negative number and I would have come out with a problem. Okay. So now I need to go back in and then set this up for each one. Let me kind of go down here like this to continue. Okay. So I select 1. X equal to 1/2. Okay. And then I'm going to go and I'm going to say 1 over 1/2 squared minus 1 over y squared is equal to 1. I can do either problem. This is 1 divided by 1/4. And then 1 divided by 1/4, I invert and multiply. So this is 4 minus 1 over y squared is equal to 1. Bring this over here, 4 minus 1 is equal to 1 over y squared. My 3 is equal to 1 over y squared. Then I'm going to cross multiply here. So y squared to both sides and then divide by 3. That gives me that. Multiply both sides by y squared. 3y squared is equal to 1. Divide both sides by 3. And now here y is equal to plus or minus the square root of 1/3. Okay, so for 1x, this is what I've got. So for the 1/2, I have got plus the square root of 1/3 and then 1/2 minus the square root of 1/3. Okay. And then what about the negative 1/2? So then I would do the negative 1/2. I would change this to negative 1/2. This would be the negative 1/2. This negative times the negative is a positive 1/4. 1 divided by 1/4 is 4 minus 1 over y squared is equal to 1. Bring this over here. 3 is equal to 1 over y squared, or y squared. So this is 3 is equal to 1 over y squared. Multiply both sides by y squared. Divide both sides by 3. That gives me this. And then it's the same thing. So here I add in negative 1/2, square root of 1/3, negative 1/2, negative the square root of 1/3. Okay, so I just changed the sign up here. So that looks crazy. So let's go into Desmos real quick. Let me get over here. So 1 over x squared minus 1 over y squared get over here, minus 1 over y squared, and that is equal to 1. And then 2 over x squared minus 1 over y squared is equal to 5. Okay, so this is really crazy looking, but if we zoom in, I think what we will see, I can't have x, y, even though this point is here, I can't have x and y equal to 0. So this one is a bogus solution right there. Okay, so we have to get rid of this. But we should have 4 solutions. And if I look at this one, not going to get us this thing. No. Let me plot this. So let me go here. Let me plot a point. Let's do 1/2 comma 1/3 to the 1/2. So if I look here at the 1/2, this is this with this label, there's that solution where it goes across. Okay. Control C, add me another one. Control V, and if I go here to, let me bring these back out. I've got all the variations of this. Wants to keep jumping between my screens. So then I've got the negative 1/2, so I'm just going to change this sign to negative and give me the label. Control V, I'm going to go with this one as a negative. Add my label. Control V, and let's see. Negative 1/2. And negative. Okay, so this were the 4 that we came up with, and here's the crossing points. Give me the label on that one, and that's that one. Okay, so I was expecting 4, we found 4 in here. Okay, let me see if there's any other good things that we do. And basically, we will look at some of the applications in what we're doing in our lab. So I'm going to stop right there. Do one more for us. X squared plus y squared is equal to 17. And then x squared minus 2y squared is equal to negative 31. I could multiply 2 here and then add or just subtract. Here's my 1, here's my 2. These are coupled together. I want solutions that work for both of these things. So here I've got the very same thing, so I'm just going to subtract, okay? This minus this is going to get rid of this thing. Okay, So I've got x squared minus x squared, that's 0. Y squared minus a minus is plus 2y squared. So 3y squared, negative negative is positive 8, and then 48. Okay. So y squared, 48 divided by 3, I think that's going to be 16. 3 sixes, 18, 3 ones are 3, and that gives me the 4. Okay? So y squared is equal to 16. Y is equal to, take the square root of both sides, plus and minus. So plus and minus 4. So I'm going to take each one of these things. Here's my y's. Let's start out with plus 4, okay? So x squared plus 4 squared is 17. X squared plus 16 is equal to 17. Minus 16, x squared is equal to 1. 17 minus the 16. So x is equal to plus or minus 1. So from these, I get two solutions. I get my plus 1 from here, and this is the same thing. There's my 4. And then plus 1, sorry, my minus 1 for my x, and then plus 4. 1, 4, negative 1, 4. From this 4, I get two x's. There's my x's. Okay, and then I get to do the other one. Y is equal to minus 4, and luckily, this squares out to be the very same thing, so I get x is equal to plus or minus 1. This is the very same thing here. So here, plus 1, negative 4, minus 1, negative 4. And those are the 4 solutions. 1, 4, negative 1, 4, 1, negative 4, negative 1, negative 4. And again, real quick, let me see if I can grab my Desmos. Oh. Here, go with this one. Where's my Desmos? Put it up. X out, slide this over here. X squared plus y squared is equal to 17. So I get a circle out of this one, and then x squared minus 2y squared is equal to negative 31. So there's our solutions. Let's see if we can get it built up here. 1, 4, that was one of our solutions. 1, 4 was one of our solutions. 1, 4, 1, negative 4, minus 1, 4, negative 1, 4, and that's all of our solutions. Okay, sometimes it is more useful to do the graph just to make sure, is there any solutions that I'm looking for? I'm not expecting any solutions. No use in even going through the analytical method. Okay. And if all you need is some answers, I mean, those are kind of the answers for you to start with. Okay. But practice going through the analytical method as much as you can just to get practice.